Hi there, this is the ET-562 Group 5 project. My name is Colin Milligan,
My name is Matthew Nojos.
And my name is Horacio Gonzalez.
and our project idea is planning to implement a CI/CD pipeline for a Python web Flask application. We want to integrate GitLab CI with Ansible to automate software delivery. GitLab CI will handle testing, while Ansible will configure and automate deployment to the production environment. We plan to have the pipeline trigger automatically when we commit our code. This ensures the application is tested before Ansible playbooks run to configure servers, install dependencies, and deploy the Flask application in a consistent manner. So my portion was the AWS and Security Cloud infrastructure. We're hosting with AWS over EC2. Um, that instance is serving as a primary production server. We're doing the infrastructure security controlled by private SSH keys, and the keys are ensured, the security is ensured with chmod 400 on the private key, preventing unauthorized access. The automation with Ansible, infrastructure as code. Ansible is used to automate the entire setup and deployment process. Environment configuration, the setup Flask env YAML playbook handles the initial prep of the server, also providing dependencies for the Flask environment. Application deployment, the deploy Flask YAML playbook pushes the code to the AWS host during the infrastructure setup stage. And then service management, a Jinja 2 template, which is named Flask App Service J2, is used to define the systemd service, ensuring constant running on the server. We also implemented NGINX reverse proxy. Um, it's using a Jinja 2 template to implement that proxy. Uh, NGINX sits in front of the application to manage incoming traffic and route to the Flask server. And then for deployment integration, the configuration is updated and deploys as part of the production merge process. This ensures the live environment reflects the latest settings.
My portion was to set up the GitLab project, including the two branches, starting with the production branch. The production branch is where we kind of do all the testing and changes all the code uploads to. Next slide. The production branch is the main live environment. So it's configured, it's a protected branch. So once we create and merge, it go to the production branch. It triggers the pipeline to and must succeed for it to actually make complete that merge request to the production branch. Next slide. This is the overall the GitLab -ci YAML file. Kind of configured it configured it right, configured to when the pipeline will run, configured to install the dependency before the testing occurs. And it's set up to have three stages: the code check, the prepare AWS stage, and the test deployment stage. The code check is where it checks the code for quality and style consistency using isort, black 8, and pilot. Isort is using like black like profile, kind of keep them unified, while black and pilot are set to check the code, but to allow it through without failing the stage. Next slide. The infrastructure setup stage, or the AWS stage, is where the SSH key is secured and next to the AWS host, followed by the first Ansible playbook mentioned before. The setup Flask environment the YAML file is ran to kind of prepare the host for the deployment, followed by the next playbook runs afterwards, which would be the deploy Flask YAML, and that's where it deploys the code to the AWS host. The test deployment is configured to run if the prepare AWS state succeeds. If it has failed, it will not run. It runs a test suite against the live AWS instance to verify it is up and running. Next slide. And then Image next to here is kind of the merge request. Once it has been created, it kind of starts the pipeline, and it will starting with the code check, followed by the prepare AWS, and then so forth the test deployment. Next slide. Screenshot here kind of demonstrates the code passing each of these stages. Next slide. Once pipeline is passed and you have three check marks, merge button becomes available to click and to complete the merger between the pre-production and the production batches.
Okay, so now let's talk about the actual application that we build uh, for this pipeline, which is the Aggie Weather app. So this app was completely built using Flask as a web application, and this basically shows real-time weather data for any city in the world. We are using the Open Media API, which doesn't require any API key and is completely free. And all of our APIs are completely free. Um, so we have four different routes endpoints. The first one being home, which is the main page. Then the weather for the results when we search for a city, and then a history, which is basically retrieving data from a local database, storing all of the past searches, and an about page for team information and other important information. We're using Jinja 2 templates for the HTML code, and that's basically our main base layout. So we're pretty much using the same approach that we saw in previous assignments during the class. Also, we are storing everything in an app folder, which contains the app.py file, requirements, templates, and all other files, which are copied to the server by Ansible. Next slide, please. Okay, so now how does the application work? Well, we're using Open Media API, which is completely free, as I said, and it returns the current conditions, forecast, and air quality, among other data. Um, we're using this API. So when we search for a city, we first have to geocode that information into latitude and longitude coordinates, and we send that to the API. So the next step will be when we fetch the weather and we graph all this information. We also can get a 7-day forecast, UV index, precipitation, and other important stuff from the same API. Also, we're using another API for the air quality condition. It is also from Open Media, but it goes to a different endpoint. Next slide, please. Okay, among the app features, we have added a toggle for the temperature, so we can switch between Fahrenheit and Celsius degrees. Um, and the preference is saved in the browser, so it will persist across your searches. Also, we have a city autocomplete. So when you start typing a city, you will see different suggestions for the city you're looking for. For example, in this image, I took Paris, Texas, or Paris, France as an example, and we're using that to send to the Open Media API. Then we can also set a specific city as a favorite or just pin it, and it will appear on the home screen. Once you pin it, you just click on the heart on the city, and it will appear on the home screen. And the other one is an interactive radar map, which shows past information of the clouds and rain, and it's powered by leaflet.js, which is displaying the current map, and is using a different API, which is called Rain Viewer, to animate the precipitation, clouds, and all that kind of stuff. Next slide, please. Okay, the SQLite search history. So this is where all of the searches are stored. So right now, our application initiates a database. It runs initiates a database when it's created. which is the init db function. If it's not created, it will just create a new one. And this will persist across rebooting and other stuff. And it will store basically all of the successful searches that the system receives. This stores the city, country, temperature, condition, wind speed, and a timestamp of the searches. I also try to put a SQL parameterization so that we can avoid SQL injection from user input. And what else? Oh, the history page only displays the last 20 most recent searches. Next slide, please. Thank you.